Content. So these are the content, the subtopics that will be covered in this topic 5. As you can see, we have 7 subtopics only. Okay, we're going to start with introduction to organic chemistry. Okay, and then isomerism. I believe that you have been taught about isomerism before. Okay, so the word isomer. Okay, and then we have hydrocarbon, compound that have hydrogen and carbon in it. And then we have alkyl halides, alcohol, aldehyde and ketone, carboxylic acid and its derivative. So these are the one that will be covered in our topic, guys. Only this 1, 2, 3, 4. Okay, this is alkane. We have alkane and alkene like that, kan? Okay. Alright, so these are the only homologous series, and then later on the functional group that will be covered in our topic. You know, we have a lot more functional groups sebenarnya. We have amine, we have ester, what else? Amide. Okay, amide, okay, but we are not covering that part. Okay, kita ada banyak lagi, tapi ini je yang kita cover. So this is already considered as, you know, helpful lah, sebab banyak, you tak payah nak hafal banyak compared to last time, guys. Okay, a lot of the content have been removed. Okay, so use this opportunity to help you boost your mark in your exam later. Okay, kalau you nak compare dengan metrik ke apa, you pergi tengok syllabus dia dekat organic chemistry, berapa banyak, berapa belas kot dia cover. But you guys only cover this one. Okay, in terms of information tu, they got more information lah. But, yalah, yang penting, the target, the focus is for the exam. Okay, maybe later if you like to go into detail in chemistry ke later on, you akan further into chemistry. Then you will go into detail on organic chemistry. So that's the plan lah. Okay, you akan belajar lebih detail. So for this one, this is like macam foundation punya level. So these are the important homologous series that you should know. Okay, alright. Okay, let's start with 5.1. Bismillahirrahmanirrahim. Okay, introduction to organic chemistry. So these are the learning objective that you should know. Okay, make sure that at the end of this subtopic, this 5.1, you are able to cover all of this. Okay, alright, so let's start. So intro, okay. And organic chemistry is a branch of chemistry that studies carbon compound. So the focus is on the carbon. Okay, all right. Why carbon? Why of all the elements in the world, why carbon is chosen as one of the topic in chemistry, organic chemistry? Okay, because carbon has a lot of, a lot of specialties. Okay, one of it, carbon binds to one another to form chain of varying length. Okay, this also known as catenation. Okay, so they can carbon can combine with one another to form different chain of varying length. Okay, that's why we have ethane, propane, butane, pentane, and so on. Okay, all right, and then carbon binds with other atoms such as sulfur, hydrogen, oxygen, nitrogen, and phosphorus, and also halogen. Okay, not only that, it has the ability to combine with other other element as well, other atom, and it can also form cyclic ataupun ring. Okay, so normally it would be a long chain yang panjang, but it can also form a ring. Okay, meaning that the carbon, okay, will eventually meet one another and form a cyclic. Okay, jadi macam cincin kan. It has the ability to do that, and then carbon can form single, double, and triple bond as long as it is octet. Carbon follow octet rule. Okay, so it must achieve octet either from having all single bond, or it can also have double bond or triple bond in order to achieve that octet. And then it can also bind with metal. So if it binds with metal, it is known as organometallic. Organo stand for organic, metals, metallic stand for metal. Okay, and then one good thing, one specialty of apa nama ni? Organic compound. Okay, they can be found in all three states. Okay, it can be either in solid, liquid, or gas. Okay, in standard form lah, normal condition. So solubility of organic compound in water varies. So it has since we have a lot of organic compounds, kan? So definitely it will affect the solubility of the compound in water. Okay, some may dissolve in water, some may not dissolve in water. So what are the characteristics that cause that to happen? So based on dia punya kepanjangan rantai dia, kan? So lagi panjang rantai dia, the more hydrophobic it becomes. So the more the more it resists water. Okay, lagi dia tak nak join dengan water. Sebab if water is polar, right? Water polar, kan? So organic compound ni normally dia non-polar kalau without the hydroxyl group, the carboxylic group yang tu. Okay, alright. Due to the existence of millions of organic molecules, they need to be classified in a systematic approach based on their reactivity. Okay, alright. And then one more thing, carbon is one of memang the most abundant element found in the world. Dia yang paling banyak. That's why we need to study about carbon. Okay, a compound having carbon. And then we have to have strategy. Okay, we need to classify all these compound into a systematic approach. So how do we assign, okay, how do we differentiate this kind of hydrocarbon dengan this other hydrocarbon? Okay, so we are going to be based on their reactivity and so on. So we have to have a systematic approach. Okay, right. On. And there you go. We have functional groups. Okay, group yang function. Okay, functional group is the focus lah. Okay, so organic molecules are systematically approached, classified them based on the functional group present in their structure. So we are going to classify them. We have a lot of compound, right? We have a lot of organic compound. So how are we going to classify them? Okay, into their own category. Okay, so kita kena ada fokus dekat situ. So we are going to be based on the functional group that the molecule has. Okay, because that will be our target. So functional group is even how big the molecule is, berapa besar, berapa panjang pun tak kisah, the target will be the functional group. Okay, kita akan classify dia based on functional group dulu. That will be the first step, and then later on dia ada lagi steps dia. So functional group is an atom or group of atom within molecule that is responsible for the chemical behavior of the molecule. Okay, why do we target functional group? Because they're responsible for the chemical behavior. It's like the taiko tie kat situ. Dalam molekul yang besar-besar tu, you target for the functional group. Okay, so kalau you nak the reaction to take place, you have to target the functional group. If you just randomly react, it won't. Yeah, dia may react ataupun dia tak ada reaction. So you have to study. Okay, when you want to attack a gangster, you nak get rid of the gangster, kan? You kena identify, okay, siapa dia punya taikotai kat atas tu, kepala dia kat situ. You kena target dia tu. Kalau you setakat layer-layer bawah ni, okay, it won't go anywhere. Okay, because the taikotai is still there. Okay, that's example lah. The chemical behavior of a functional group are the same irrespective of the size of the molecule or where the functional group is located in the structure. Okay, as long as they have the same functional group, therefore they will have the same chemical behavior. Macam gangster dia lah, dia mesti ada dia punya style dia punya routine ni, kan? Gangster ni style dia macam ni, gangster ni style dia macam tu. Dia depends on the functional group. Okay, so regardless how big the molecule is, how panjang the molecule is, the shorter the molecule is, as long as they have the same functional group, they will have the same chemical behavior. I'm talking about chemical behavior, okay? Not the physical. Physical, of course, dia akan varies. Tapi chemical behavior, it will be the same. Okay? Homologous series and functional group. Okay, students tend to get confused between homologous and functional group. They confuse, so later we will see what's the difference between these two. How do we identify? Is this a homologous ataupun functional group? Okay, all right. So compounds having the same functional group are classified under the same homologous series. If they have the same functional group, it will be considered ataupun categorized under the same homologous series. Okay, all right. Homologous series ni is like the family name now. Family name. Tapi family name, tapi nama-nama anak-anak dalam tu nama lain-lain, tapi family name ni sama. Macam tu lah contohnya. Okay. Characteristic of molecule of the same homologous series. So these are the characterization of the homologous series. It can be represented by the same general formula, have same functional group, therefore the same chemical properties, can be prepared using similar method. Successive member differ by a CH2 group. For example, like I've said just now, we have CH3, CH2, CH3. So this is propane, right? Okay, and then next we have CH3, CH2, CH2, CH3. And this is butane. Okay, so dia punya pertambahan dia, beza dia is this CH2. Additional of CH2. So it was successive member. So we have pentane and then another CH2 added. And then we have hexane, butane, pentane, hexane, and then another CH2 added. Okay, right. Physical properties like boiling point, density, viscosity, and whatnot are progressively changed with increasing molecular mass. Okay, right. Right, so these are homologous series, guys. Nama-nama ni considered as homologous series. These are not functional group. Faham? Jangan confuse. Ini yang you panggil alkene, alkenes, alkyne, alcohol, aldehyde. These are all homologous series. Okay, alright. So these are the general formula, example, and the structural formula of it. Okay, alright. So now baru kita boleh nampak homologous dengan functional group. See the difference. Okay, alright. Alkene, this is the name of the homologous series. Tapi dia punya apa nama functional group because dia tak ada functional group. Alkene ni tak ada functional group. Okay, that's why dia none. Sebab basically dia all single bond. Single bond ni kan basic of the bond kan, the basic bond yang akan ada dalam molecule. Okay, alright. So maybe we can look at alkene. Alkene is the homologous series. Tapi when we are talking about functional group for alkene, it is named as carbon-carbon double bond. You can spell out. If you were to represent ataupun draw the functional group, you have to have C double bond C. This is functional group. Alkene is not functional group. Alkene is called homologous series. Okay, so jangan confuse. Kadang-kadang yelah kita guna tukar-tukar kan, tapi by definition alkene is homologous series, not the functional group. Okay, alright. Alkyne, triple bond. So this is in terms of the structure of the functional group and how do you spell it. Kalau you nak tulis, it should be carbon-carbon triple bond. Okay, so this is propene. Okay, so this highlight. So this is the functional group. This is a functional group. But as a whole, okay, this is alkene. This is alkyne as a whole. Okay, guys. All right, based on the presence of functional group in the molecule. Another example, homologous series, alkyl halide, guys. Okay, alkyl halide or also known as haloalkyl. Haloalkene. That means we have alkane and then we have halogen. Ataupun alkane, alkyl, and then halide is halogen. It's the same lah. Okay, this can be used interchangeably. Okay, how about functional group, guys? Okay, so one of the hydrogen is being replaced with halogen. So the name of the functional group, what is it called? It is halogen atom. Bukan alkyl halide. Alkyl halide is a homologous series. Okay. Alright, so the name of the functional group is halogen atom only. Alcohol, alcohol on the other hand, see? Okay, this is the general, general formula. Okay, general formula, Rx. That means we have alkyl group. Alkyl group can be anything. It can be butyl, it can be propyl, hexyl and whatnot. I mean, different chain length lah, it can differ. So that's why they letak in general to represent the organic compound. We usually use R. Okay, so X is halogen. Memang untuk halogen. So kita tak boleh simply dalam organic chemistry kita tak boleh simply pakai unknown tu tau, sebab unknown tu represent something. Okay, kita kena choose something else yang tak related to X. X is known as halogen. Okay, homologous series for alcohol, okay, it is known as alcohol. Tapi bila cakap functional group, it is known as hydroxyl. Student, bila saya cakap, okay, functional group untuk this molecule apa? Alcohol. Saya tanya functional group. I'm not talking about homologous. Okay. So when you say alcohol, you are referring to homologous. Okay. So please be careful. Don't get confused. Alright. So hydroxyl is the name of a functional group. So how do you represent hydroxyl? This is how. OH. This is hydroxyl. Hydro, and then you have ox ni, because it has oxygen. So this compound is considered as alcohol. The whole thing is considered as alcohol, but the functional group is this one only, this OH only. Ether, okay, ether is a homologous series, so this is how it looks like in terms of functional group. But how it is named as oxygen between two alkyl group. Okay, that means the oxygen is located in the middle between the two carbon. Okay, right. Let's look at another example of homologous series. Okay, so you nampak Okay, homologous series, this is known as aldehyde, CHO. Okay, this is different than this one. Okay, guys. Okay, kalau alcohol dia OH. COH. So kita letak R lah. ROH. H will be at the end. Tapi for this one, aldehyde, H is in the middle. Okay. Ni nampak, HO ni macam alcohol. No. Usually if we represent aldehyde this way. Okay. We use this general chemical formula to represent aldehyde. So H we usually place at the middle between the carbon and oxygen. Okay, so we have aldehyde, and then later we have ketone, right? Okay, so how the structure wise, this is how it looks like. Okay, C double bond O, and then it is attached to hydrogen. But for ketone, C double bond O is at the middle, so it is placed at the middle of these two carbon. We have these two carbon. Okay, see, look at the name of the functional group. They have the same name of functional group. Carbonyl. Carbonyl represent this one, C double bond O. Okay, yes, they both have C double bond O. It's just that the homologous series is different. For aldehyde, dia mesti attach, satu lagi tangan dia tu mesti attach to hydrogen. You have to make sure that the carbon, each carbon in the molecule should achieve that 4 bond. 1, 2, 3, 4. Sebab dia follow octet, dia mesti cukup tangan dia. Okay, so dia mesti located, aldehyde dia mesti located at the end of the chain. Tapi ketone dia duduk dekat tengah-tengah chain. Contoh, cuba tengok ni. See, this is propanol. Okay, they both have carbonyl group. This is what we call carbonyl group. Nama functional group kan? So carbonyl group. Tapi aldehyde, one of the bond should be attached to the hydrogen. So this can only happen at the end of the chain. Okay, the terminal chain. Yang hujung. Tapi kalau ketone, dia duduk dekat tengah-tengah. The carbonyl is located in the middle of the chain. Okay, So dia mesti ada apik 2 lah at least. Dia panjang-panjang tak kisah, tapi dia mesti in between the carbon. See? They both have the same functional group, tapi homologous series dia berbeza. Right? Alright, okay. Next, we have carboxylic acid. Carboxylic acid. Okay, so this is the chemical formula in general for carboxylic acid. This one, okay. This is, I believe you have already familiar with this one. Okay, carboxylic acid, you have C double bond O and then OH. So this is different, slightly different than aldehyde. Okay, nampak tak? Aldehyde dia hydrogen, but carboxylic acid dia mesti OH. Aldehyde must be attached to hydrogen, but carboxylic acid you have the carbonyl and also the OH. So they become apa? Carboxyl. Carbo come from the carbonyl and then oxyl come from the hydroxyl group. So they become carboxyl in combination. Okay? So homologous series, carboxylic acid. Functional group, carboxyl group. Okay? Alright, so this is another example. The same number of carbon, it's just that they have different functional group. Okay, so you can see that the name change, obviously lah. Okay, right, and then we have ester. Okay, so ester is a homologous, so this is how it looks like. Okay, bila normally carboxylic acid combine with alcohol, it form ester kan. So nampak tak? Sepatutnya kan ada H kan, so H is removed. Later we will see, we will learn on the reaction of carboxylic acid. Okay, you akan tahu macam mana at the end dia jadi begini. Okay, alright, so C double bond O. Yang ni beza sikit, dia duduk dekat tengah. Ester kan, dia duduk dekat tengah, tapi initially it has OH, now dia jadi O saja. And it is in the middle ataupun between the carbon. C, what's the name of the functional group? It is carboalkoxy. This one is the carbonyl. Okay, remember yang tadi alkoxy just now? This one, ni alkoxy. This is also known as alkoxy tau. Another name. So nampak tak? COC. COC, alkoxy. So kat sini nama dia carbon alkoxy because we have carbonyl and then alkoxy, when this carbon we have O and then we have C. Kan macam yang ether just now, COC. That's why it become carboalkoxy. Okay, tapi ester maksudnya when the homologous series homologous series is specified as ester, dia consists of this. Okay, and then we have acyl chloride. Okay, just now ganti hydrogen ke tadi OH tu ganti with Cl. Tapi dia ada carbonyl, still ada carbonyl, so that's why nama dia carbonyl chloride. Okay, and then amine. Amine maksudnya this. Remember ammonia, you must have familiar with ammonia kan. Maksudnya dia mesti ada 3 hydrogen. So now one of the hydrogen is being replaced with this molecule. Okay, so this is amine. Bila the nitrogen is directly attached to the carbon. So the name of the functional group is amino. Okay, moving on, and then nitrile. Nitrile is a homologous series. So this is how the functional group looks like. Okay, remember cyanide. So the name of the functional group is known as cyano. Cyanide kan poison tu. Okay, it's very dangerous if consumed more than the allowed amount. So because of this, the presence of this functional group, so it is called cyano. Okay, tapi kategori di nama homologous series dia nitrile. This is nitrile group. And then we have amide. So what's the difference between amine and amide just now? Amide dia ada carbonyl. Amine just now, we don't have carbonyl. We don't have double bond O. But amide, we do have double bond O. But we still have NH2 lah. Okay, it's just that we have an additional of oxygen. So this is what we call carboxamide. Okay, carboxamide. Okay, and then we have arene. So this is aromatic ring. Okay, this is the benzene that you usually see in question. Okay, so this is aromatic ring. So this is a functional group. Okay, the functional group is known as aromatic ring. Tapi homologous series is known as arene. Right? As checkpoint. Okay, try to complete this one first. Okay, I give you 3 minutes, and then once the 3 minutes is up, I'm going to call names. Dah lama tak panggil nama kan? Okay, so please be prepared. Okay, 3 minutes for you guys. Okay, all right, are you done?
Yes, madam.
Okay, how about the rest? Are you all done?
Belum.
Yes, madam.
Belum. How many of you who still haven't finished? Satu je tadi respon.
Belum siap, madam.
Okay, I give you another 1 minute. Okay. Okay. Alright, so let's look at how do oops, lama ternampak pula kan. Issue. Okay, tak apa. It's okay. I have a list of your attendance in my hand. Okay, alright. So let's have let's start with S13 first. Let's have Zahin. Zahin for A. Okay. Identify the functional group. So what's the functional group that we have for A?
Carboxyl, madam.
Sorry, I can't hear you.
Carboxyl.
Carboxyl. Carboxylic acid ke carboxyl ke apa?
Just carboxyl.
Okay, alright. Moving on to Nurin Inshira for B. Nurin, what's the functional group for B?
Carbonyl.
Carbonyl. Okay, moving on to Tengku Afif Helmi. Afif?
Yes, madam.
What's the functional group for C?
Hydroxyl.
Hydroxyl. Okay, alright. So let's switch to S14 now. Okay. Azri. So what's for D?
Carbon double bond.
Carbon double bond. Okay, next. Ama?
Yes, madam.
E? How about E?
E carboalkoxy.
Carboalkoxy. Okay, alright. F, Huda, Nurul Huda. Huda? Nurul Huda binti Abdul Aziz. Can someone please check, do we have Huda in our session?
Ada.
Yes, madam.
Huda. Okay, Huda for F.
Halogen atom.
Yeah, right. Halogen atom. Okay, alright. So even though, patutnya saya tambah soalan tadi Identify the functional group and also the homologous series for the following molecule. Okay, patutnya saya kena tambah. You kena tambah lah kat situ. Warm up kan. You kena make sure that you remember, you know how to differentiate between the functional group and the homologous series. Okay, alright. So you are given this molecule. Okay, so what you need to do is to highlight the functional group. Identify of all the given, you have a bulky molecule such as this. Okay, you can identify where is the functional group. Okay, so once you have identified the functional group, so it will be easier lah. That means the target ataupun if you want to perform a reaction, the target will be this functional group. Okay, so COO, because this part is quite stable. Okay, it will be very difficult to jeopardize this part of the molecule. But for the functional group, we can target there because dia ada apa orang kata dekat situ, dia ada weakness dekat situ. Okay, kita boleh identify the attacker ataupun kita nak attack dia with something else, kita akan attack kat kawasan ni. Okay, so that is in terms of reaction lah. Later on will be covered in the later slides. Okay, so this is the functional group and it is called carboxyl. But the homologous series is what we call is carboxylic acid lah. Okay, carboxylic acid. This one, like I said, okay, so this is carbonyl. Don't get confused dengan alkohol Alkohol pun nanti ada alkohol dia sepatutnya buat macam ni. OH, COH. But this is H dulu. H is in the middle. That means this is most likely carbonyl. Ataupun to be specific, the homologous series is aldehyde, not the ketone because satu dia dekat terminal, nampak? Okay, if you were to expand this, okay, contoh yang ni kan, you nak expand, you kembangkan how it look like, dia akan jadi macam ni. C, okay. Alamak, saya dah terpadam lah pula semua okay, so you kembangkan, you akan dapat double bond O, and then single bond OH. You must make sure that the carbon must have 4 bonds attached to it. Satu double bond, satu single bond dengan OH, the other one with this carbon. Okay, cukup, dia mesti octet. Okay, same goes to this one. Kalau OH, dia tak cukup bond. Okay, you imagine kalau saya kembangkan jadi, dia jadi OH dekat sini. OH. Okay, OH. So, ni, how about this one? Ni. Nah, tak apa. Ikutkan tak ada apa-apa ni, dia letak CHO kan. So, dia bukan OH, dia sepatutnya this one. It's supposed to be carbonyl group. Okay, CO and then H. Ni assume this is the single bond attached to H. Okay, alright. So this is aldehyde. The homologous series is aldehyde. So this is hydroxyl. Okay, this is hydroxyl ataupun homologous series is alcohol. Okay, this is alkene, homologous series, but for the functional group it is C double bond C. Okay, alright. So this is the functional group, and this is the functional group. So this functional group is named as alkoxy just now. Carboalkoxy kan? Carboalkoxy, carbonyl, and this one alkoxy. That's why carboalkoxy. P homologous series, it is called ester. Okay, alright. F. So this is the only foreign atom. Okay, compared to the rest, we have carbon dengan hydrogen kan. Suddenly we have Cl. So this will be the functional group. This is chlorine atom just now. Okay, so homologous series is known as haloalkane. Dia halogen and then alkene. So these are all alkane kan. Okay, alkene part. Alright. So these are the answers. Okay, moving on, representation of organic molecule. Still masih dekat introduction. Okay, now kita dah tahu the characteristic, in general, the characteristic of organic molecules, the introductory part. Okay, the very basic of organic molecules. And then how do we represent the organic molecules? Okay, how do we represent the organic molecules? How do we write? How do we describe the structure? Okay, so how do we know that they will be categorized into functional group? Kita tahu ada functional group, tapi kan dia the same functional group, but dia punya apa size of the molecule different, okay, and the chain length is also different. Okay, so how do we represent them? Okay, so we get more specific into that. Yang tadi more general. Okay, this one kita dah get into more specific detail of the organic molecules. So we can represent the molecules, the organic molecules, by molecular or structural formula. Okay, so we have two formula. One is in terms of molecular formula, the other one is structural formula. So molecular formula give the type and number of atom present in a molecule. So this is quite limited. Information yang kita boleh dapat is very limited because we only know how many atoms are present in the molecule, and then type of molecule. Is it carbon? Is it a metal? Okay, is it halogen ke? So itu je yang kita tahu. But how they are arranged in the molecule, we don't know. We don't have that information. Okay, so molecular formula is quite limited. That is why we have structural formula. Okay, so structural formula present the arrangement of the atom in the molecule. It allows us to know how the carbon ataupun how the whatever atom that we have in the molecule are arranged in the molecule. Okay, take for example, okay, so this is the molecular formula. Okay, so based on the molecular formula, we just know that we have 2 carbon, we have 7 hydrogen, and then 1 nitrogen. But how it is arranged, we don't know. We don't have that information. It can have, different arrangement in the molecule. Okay, in terms of the structural formula. So that's why I said just now, molecular formula, the information is quite limited. Okay, same molecular formula can give different structural formula. So structural formula is like more specific version of molecular formula lah. Okay, because it allows us to know, okay, carbon is actually bonded to who? Oh, carbon is actually bonded to hydrogen, and the nitrogen is bonded to the carbon, not to the hydrogen. Nampak tak? The specific information guys tu. Tapi kalau daripada molecular formula, we don't have that information. Okay, alright, so rupanya this chemical formula, molecular formula, have 2 different structural formula. One, this is formula 1 and this is formula 2. Formula 1, the amine group, okay, the amine group is located at the terminal. Terminal means tepi lah. Okay, another option that still satisfy this molecular formula is this structure. The nitrogen is located in the middle between the carbon, okay, and then and it is still satisfy this molecular formula. Dia follow, dia still C ada 2, H ada 7, nitrogen ada 1. See? So they become more specific. Right, so we have different type of representation of structural formula. Okay, so kita boleh represent the structural formula tu into 4 different ways. The one that you normally learn during your school time ataupun SPM time is this one. It's what we call expanded version. Okay, where everything will be displayed ataupun everything will appear. All the bonds, all the atoms will appear. Okay. Alright, so this is the one. So expanded, kembang, everything will be seen. Another version of it is condensed. Condensed is like macam compact. Okay, so you can see the difference between, this is actually the same molecule. It is called butanol, 2-butanol. Okay, so it can be represented using expanded, condensed, skeletal, and 3D. Okay, this is condensed looks like. Okay, guys. So condensed basically ignore the bond. They ignore the bond. They compress everything. Okay. So kita jimat masa dekat situ. Jimat masa, jimat space. Okay, kalau yang macam saintis yang dah tinggi-tinggi, yang pro-pro tu, dia tak ada masa nak expand benda ni. Okay, dia nak sesimplify mungkin sebab dia banyak lagi kerja lain nak buat daripada nak melukis. You imagine kalau we have a bulky structure. Okay, so condense is another way to represent the molecule. Okay, so how can you prepare the condense? Basically, you condense kan, you remove all the bonds. Okay, so you focus. Okay, we are going to target for this carbon, right? So this carbon, we have 3 hydrogen attached to it, right? See this one. Dia ada 3 hydrogen, CH3. So this hydrogen belongs to this first carbon. Okay, and then the second carbon, so this is the second carbon. So you may use expanded as your reference. This second carbon is attached to 2 hydrogen, see? So this is the second carbon, right? So these 2 hydrogen is belong to this second carbon. So it has 2 hydrogen. Sama lah dengan this one. Dia kena tally lah, align Right, the third carbon is attached to 1 OH and then another hydrogen. So this is the third carbon, so it has 1 hydrogen, and in the bracket it shows that this one belongs to this carbon. So but you kena make sure that each carbon kena ada 4 bonds, betul tak? So this one belongs to siapa? This one belongs to this third carbon. So you normally kalau kita pakai bracket tu sama ada dia repetitive ataupun dia branch ataupun dia functional group. Okay, we may use this what do we call this, bracket ataupun parenthesis. Then the last one is this, the fourth carbon. So it has 3 carbon attached to it. See, simple je. Okay, you compress everything. So everything is compressed, so we don't see any bonds, any lines. Next is skeletal. So this is another, ini yang paling legend lah maksudnya. Alright, so the simplest version of structural formula. Okay, where we use lines saja guys. We don't have to write the carbon. Okay, we just need line. Okay, line. Okay, so macam mana representation dia? Okay, the same thing. It's 2 butanol. So this is carbon number 1. Okay, dia punya bucu tu represent carbon. Okay guys, bucu dia represent carbon. 1, 2. Kat carbon number 3 kan ada OH kan, see? Carbon number 3. Kalau we count from here lah. Tapi sebenarnya dia kalau naming kan kita kena count the closest to the functional group. Okay, let's just ignore that one first. Kita ikut sebiji. So hydrogen, we don't show the hydrogen. Tak payah sebab kita understood, kita memang tahu that carbon mesti attach, we are talking about organic molecules kan. Carbon mesti attach pada hydrogen. So how many hydrogen that must be attached to the carbon? Depends lah, kalau dia form semua single bond, that means we have 3 carbon, 3 hydrogen attached to it and then another bond tu attached to this carbon. Okay, so normally ini kalau dia ke bawah kan, kalau straight, okay, 1, 2, 3, 1, 2, 3, 4. Always count back. Okay guys. Okay, this carbon number 1, number 2, number 3. Bucu dia tu sebagai carbon. And then kat carbon number, kalau carbon number 2 ataupun 3 here, okay, ada OH. Ni yang you akan nampak. Normally kita buat macam ni lah. Ini kesengit ke bawah kan. Siap. Sebenarnya ni ada hydrogen kan. Tapi memang dia punya approach dia, we don't show the hydrogen. Sebenarnya ada hydrogen. Tapi kita tak tunjuk for skeletal, dilarang tunjuk. What's the purpose of tunjuk? Kalau kata nak simplify, tapi kena tunjuk juga hydrogen. Tak perlu. And then 3D, last one. Okay, 3D is 3-dimensional. Normally to represent this 3-dimensional, kita akan fokus on 1 carbon saja. Because that will be our focus. Okay, and then remember yang macam kita belajar masa chemical bonding in semester 1 last time, yang saya tunjuk molecules kan, dia macam tu. Okay, dia mesti ada central atom, so kita kena pilih one of it sebagai central supaya senang kita nak draw. Okay, dia ada 4 bonds. Okay, as you can see dia ada yang solid macam ni, lepas tu dia ada Yang ni, this is what we call wedge line, wedge. Yang hitam tu. And then kita ada this one. Dashes, this is wedge. Okay, nak menunjukkan 3D. Okay, yang solid line ni menunjukkan dia same plane. Okay, same plane. Maksudnya dia satu satah. Kalau saya letak kertas, okay, kertas ni saya letakkan pen saya, ni satu satah. Maksudnya dua line tu, yang solid line tu, okay, dia duduk. Kalau saya letak kertas dekat situ, dia akan duduk atas kertas tu. Same plane. Okay, tapi yang wedge ni kenapa dia gemuk? Kenapa dia macam ni? Kenapa dia macam ni? And then the other one tu, kenapa ni dia hitam, the other one tu dashes. Kenapa dia macam tu? Sebab wedge yang hitam tu, okay, the one that we see at the front, okay, going into the sea. Maksudnya kita nampak dekat depan. Kita nampak dia dulu. Okay, and then yang dashes tu kenapa? Sebab dia dekat belakang. Dia duduk dekat belakang. Okay, so itulah 3D. So that normally kita akan target satu atom lah sebagai our focus. So that is the introductory part. So kita akan cover each one of them in the later slide. You akan tengok. So at least you ada idea of it lah. Okay, so kita repeat 2 kali guys. Okay, so kita akan go one by one. Okay, so we're gonna start with expanded first. Like I said, expanded we show every atom and type of covalent bond in the molecule. So all will be visible. You kena tunjuk everything. You tak boleh condense satu pun. Sometimes kita boleh campur-campur macam ni. Tapi if the question asks for expanded, you buat macam ni. CH3 ni you condense, the rest you expand. This is considered wrong. Because if the question specify expanded, the molecules need to be in expanded form. Everything need to be expanded. Okay, you cannot just simply condense and the rest. This is what we call mixture of molecule, mixture of structural formula. Kalau dia tak specify, tak apa, it's not wrong. Tapi if the question specify, you still give this mixture of structural formula, sorry, salah. Everything need to be expanded. See, so normally kita buat macam kan, NH2 kan? No, you cannot do that. You have to expand. H, expanded. Okay, alright, kena expand. This is wrong. Okay, next, condense. Like I've seen, like I've mentioned to you just now. Okay, it shows the order of atom in a molecule, but are written in a single line to save space and make it more convenient to write. Okay, save space and then in single line. So this is the expanded version. So this is a condensed version. As you can see, berapa banyak space yang kita boleh jimat dekat sini. Okay, if we were to jimat some more, nak jimat lagi, malas nak tulis lagi, kita boleh ni. Kan, as you can, ni nampak tak repetitive? Dia berulang. Okay, you may use parenthesis ataupun bracket to show that it is repetitive. Maksudnya dia ada 2 kan? So, you have CH2 in bracket and then repeat 2 times. Macam gitu. Okay, parenthesis is followed by number, is used to show similar repeating unit. Okay? So kita boleh guna parenthesis. Jimat lagi masa. How about this one? Okay, CH2. You ada, like you kena fokus setiap satu ni, you kena represent. Okay, 1, okay, 2, 3, 4. So everything need to be in this condensed form. Ni adalah alternatif je. So you kena, at the end of the day, bila you kembangkan balik you punya condensed, you should get the same expanded. Kalau you dapat different form of expanded, itu salah. Faham? Bila you buat condense tu, you try kembangkan balik. Dapat tak sama macam expanded yang awal-awal tu? Okay? Alright, CH2 and then C. Dekat sini nampak Okay. These 2 hydrogen belongs to the first carbon. Right? Settle. And then it is also attached to this C. Okay? It is also attached to this C. And this C attached to CH3. Okay, so we have to use CH3. We have to use bracket. Okay, to show that this CH3 belongs to carbon number 2. Number 1, number 2. Bukan carbon number 3 punya, bukan carbon number 4 punya. Okay, this is like branch. Branch pun we can use parenthesis. Okay, alright, so we have to make sure that all the carbon should achieve octet. Tapi kalau sebab kita tak nampak kan double bond tu kan kat sini kan, tapi you kena tahu. Oh, ini macam tak cukup kan. Kalau ikutkan, kalau kita buat macam ni, ini baru 2 ni. And then dia attach kepada carbon kan. So ni tangan ni mana lagi satu ni? Tapi dalam ni hanya tunjuk 2 hidrogen saja kan. So you kena, maksudnya kalau we are using condense, kita tak nampak dia double bond. Tapi you kena fikir sendiri, you kena tahu if we only have 2 hydrogen here, so how about another 1 hydrogen? That means dia tak ada hydrogen lah. Dia form double bond. Baru cukup 4 bond. Okay, same goes to this one. Okay, dia akan attach to CH3. Okay, so dia dah this is already 3 bonds kan, and then attach to C. This one. Okay, CH. Bila you kembangkan this one, you dapat tak this expanded version? Okay, kembangkan lagi, you dapat H. Dapat H. Ini pun pelik. Ini macam tak cukup ni 4 tangan ni. Pelik kan? Tapi kita tak boleh simply tambah satu lagi hydrogen. No, because this is the molecule. Okay, kita tak boleh suka-suka, ini tak cukup, kita tambah hydrogen. No. Okay, so what are the option that we can consider? Maybe they form double bond. So, you have double bond there. So, settle lah. Semua 4. Semua octet. This one also octet. The 4 bonds. Okay, alright. So ini susah sikit lah. Version dia yang version susah sikit. Student kena tahu that kalau dia tak cukup hydrogen, ada probability dia form double bond. Ataupun the easy version adalah show the double bond. Show the double bond. Okay, so tak adalah you macam, ni tak cukup ni. Tak boleh tambah hydrogen. Memanglah. Sebab dia ada double bond. You cannot just simply add in atom. Okay, this is another example. Okay, so this is expanded version. This is, ini panggil apa? Condensed version. Okay, expanded version. See, yang kat sini. Nampak tak? Repetitive. Dia berulang 2 kali. And so you can condense it into CH2 in parenthesis 2 times. Okay, 2 subscript and then NH2. Okay. And next will be skeletal. Skeletal, like I said, is the simplest version of structural formula. Okay, it's like the shorthand representation. Paling cepat lah. Shorthand representation of a molecular bonding in which carbon and hydrogen covalent bonds are shown as line. Okay, they are shown in as line. So, example, this is the expanded version. So, how do you transform this into skeletal, guys? You kira the carbon, how many carbon do we have? 1, 2, 3, 4. Okay, so 1, 2, 3, 4. Saya buat balik 1, 2. You can start from up going down ataupun from bottom going up. Okay, so kira balik. Always count back you punya bucu tu. 1, 2, 3, 4. Okay, we have 4 carbons and then at carbon number 1 and number 2 we have double bond. Okay, carbon number 1 and number 2. So kalau you nak, let's follow the expanded version exactly. Okay, so kita belah kanan kan, so kita follow lah. So ini akan start, kalau naming kita akan start kat 1, 2, 3, 4 lah. Macam tu. Naming kita put aside dulu, okay. Alright, so this is how it looks like. Okay, ni the expanded version of apa nama tu, cyclic. Okay, nampak tak betapa dahsyatnya? Banyaklah masa kita nak meletakkan hydrogen, carbon and whatnot. But if we use skeletal, so it is understood macam ni. Ini tahu, ni C, ni C, ni semua C. And then this C, okay, dia dah ada dua bond kan, so another 2. So this will be for hydrogen. But like I said, skeletal will not show the hydrogen. Okay. Oh, ni ada, the functional group are shown. Okay, untuk skeletal, okay, Kalau carbon, single bond carbon, single bond carbon, we don't usually show the carbon-carbon. Tapi kalau dia ada double bond ke ataupun the functional group kat sini, kita akan show. Kita akan tulis the OH macam tu. Functional group, this is only applicable for OH, for functional group. Okay, NH2, Cl, kita kena tulis. Yang tak tulis tu hanya carbon dengan hydrogen saja. Okay, functional group kita tunjuk. The carbon skeletal is denoted by zigzag line joining one another. So we use zigzag line. Macam ni, ni zigzag. So ni bucu-bucu tu dikira sebagai carbon. Kita tak boleh buat macam ni. Lepas tu kita buat bulat-bulat macam tu. Mana boleh? Tak boleh. Okay, this is wrong. Carbon atoms are assumed to exhibit tetravalency. Mesti ada 4 bonds. Okay, make sure that dia ada 4 bonds. Ataupun dia double bond. 4 lah maksudnya follow octet. Okay, so this is another example. Expanded version. So this is the carboxyl group kan. How do you represent the carboxyl group? Okay, let's start from the beginning. So how many carbon do we have here? So we have 3 carbons. 1, 2, 3. 1, 2, 3. 3 carbon kan? Alright, so hujung dekat sini dia ada carboxyl group. So how do you draw this carboxyl group? Okay, so we ada double bond O sebab ni dah C kan? So kita boleh just terus je guna O. And then buruk lah sikit. Tak cantik lah, tak nak. Boleh, betul juga yang tu. Okay, tapi kalau nak bagi proper, dia sengit. Tak ada pun. OH, okay. Nak menunjukkan ada line lah kat situ. Ataupun kadang-kadang buat macam ni. Okay, yang cantiknya macam ni lah. Ni nice. Ataupun you buat ke atas. Tak, macam ni lah. Okay, nampak tak functional group you kena represent. Okay. Sometimes ada juga dia buat macam ni. Dia buat macam ni. C-O-O-H. This is a functional group. Functional group dia tunjuk. Okay, 1, 2, 3. Tetap obey. 1, 2, 3. Tetap ada 3 bond. 3 carbon. 3D structure formula. Okay, the last one show the 3-dimensional spatial space. Okay, in space, spatial arrangement of atom or group of atom within the molecule. Okay, we are going to use the wedge dash diagram as I mentioned to you just now. Okay, so we have this wedge, this is the dash, these two are the solid line. So what are these represent? Okay, what are this line represent? Ataupun kategori dia tu. Bond lies on the planar paper. Okay, in plane. Maksudnya kalau kita lay flat, kalau kita ada paper, these two line will lay flat on the paper. Maksudnya dia satu satah lah. Okay, on the other hand, this wedge yang you nampak ni, kenapa dia hitam bold ni, dia daripada depan kepada carbon. You nampak dia dulu. Sebab dia daripada, dia cakap apa ni? Bond projects outside the plane. Dia from outside going inside. Okay, towards the viewer. Ataupun daripada tu, dia towards the viewer. You akan nampak dia dulu. Okay, you central kan? And then you nampak ada bond and then you nampak that atom. Okay, so this is the forward, whereas dashes is the backward. That's why the dashes. Right? Okay, draw the expanded the structural formula for each of the following compounds. Let me check first. We have enough time to. Okay, alright, so draw the expanded structural formula for each of the following compound. You may, I think, let's make this as your homework. Okay, so saya nak samakan dengan S19 dengan S20 sebab tomorrow we will have a combined session kan. So saya bagi ni sebagai homework. So you guys pun homework lah juga. Okay, so please complete this checkpoint and we will discuss it tomorrow and then few other checkpoint later on. Okay, so maybe you need time to digest ke apa kan. So go ahead. Okay, go through balik expanded ke apa nak absorb balik. Okay, nak digest. Okay, and then try to complete this checkpoint. Okay, right. So in expanded structural formula. So why not you practice for others as well? Okay, for expanded. This is for expanded kan. Soalan nak expanded. Tapi you can also practice for condensed and also skeletal. Why not? Okay, why not? It's just for your practice. Okay, all right. Okay, so complete this checkpoint. And then checkpoint number 2, draw the condensed structural form. This one nak condense pula. Okay, you have to condense. So all of these are in expanded version. So you try to condense them. Okay, you try to condense them. Why not? You try for skeletal too. Okay, try lah for skeletal. Okay. Next, another, I believe this is for skeletal. Okay, this one, draw the skeletal structural formula for each of the following. So this is the expanded, this is the condensed, this is the expanded. Nah, ni expanded campur condensed. Ni mix. Okay, tapi you have to transform all of this into skeletal. Okay, try to transform this into skeletal. So normally student akan go for expanded. Dia nak, sebab you dah biasa buat expanded version kan. So dia akan use the expanded version and then they transform into skeletal to get that confidence. Tak apa, go ahead buat dulu. Nanti lama-lama you dah mahir, you don't need the expanded. Okay, student selalu dia akan start dengan expanded. Lepas tu baru dia slow buat skeletal, buat condense. Sebab expanded tu yang everything is clear, everything is shown. So tak apa, go ahead. You nak build the confidence. Okay. Okay. Okay, any questions so far before we proceed to the reaction part? Okay, but still under introduction to organic chemistry, but on the reaction punya part. Okay, ada soalan?
No, madam.
Tak ada, madam.
Madam.
Okay, alright, so far so good. Nampak tak ada soalan, which is looks macam okay, tapi hopefully memang betul okay lah ya. Right. Okay, moving on to organic reactions. Okay, alright. Okay, for the reaction involving organic molecules, okay, it normally involves 3 main types of reactive species. Okay, all right, so imagine we have an organic molecule, so we need to react it with something. Okay, so that something can either be free radical or electrophile or nucleophile. So these are the 3 reactive species. Okay, because why? Because normally these organic molecules, they are very stable sebenarnya. That's why dia dalam keadaan tu in the first place. So in order to attack the stability of the molecule, kita kena something yang reaktif. Okay, yang tak stable. Bukanlah tak stable as ini, maksudnya dia very reactive. Okay, dia very reactive. So when this very reactive species attack something that is stable, so it may alter something to that molecule. So that's why bila dia attack tu, so dia nak attack kan molekul tu kan banyak part kan, hydrogen, carbon and whatnot, bulky kan, very very big. So dia mesti ada target. So which part yang dia kena target? the functional group. Kat situ dia punya weakness dia. You nak kenakan orang, you kena tahu weakness dia. Kan? Sama juga. This molecule you kena target the functional group. But you kena attack with something yang suitable lah. Okay? You nak attack somebody yang very strong, you pergi hantar orang yang very weak. Okay? You rasa dia boleh attack ke? Walaupun dekat functional group. Okay? You won't be able to attack this strong molecule ataupun this strong people. Because you don't use suitable suitable species to attack the molecule. So there are 3 reactive species. Free radical, we know that it is very, very reactive. Electrophile, this is the species that has lack of electron but love electron very much. Electrophile. Okay, so you can see the charge, the positive charge there. It shows that it is lack of electron, poor in electron. Electron dia tak banyak, jadi dia suka electron tapi electron tak banyak. So dia also very reactive. And the other one is nucleophile. Nucleophile, the negative charge there, it shows that it is rich in electron. Banyak electron, tapi dia still reactive juga. Like anion, kan? Anions are considered as nucleophile. Okay, so during reaction, covalent bond cleavage occurs. So the bond in the reactant has to be broken prior the formation of new bond in the product. Yalah, okay. If we want to form a new bond, the old bond need to be broken. Okay, it need to be broken down. So if not, the new bond will not be formed. Okay, alright. So breaking the chemical bond is called fission. Other term that we can use to replace breaking is fission. It's actually breaking, tapi in organic chemistry, in organic reaction, the word fission is is more suitable to be used. Okay, but it carries the same meaning as breaking, the bond breaking. Okay, so bond fission or bond breaking consists of homolytic fission and heterolytic fission. Dia ada 2 jenis pula. Dia ada homolytic and also heterolytic. Homo sama kan? Hetero different, like homogeneous, heterogeneous. Okay, so homo means sama. So apa yang sama? Okay, later we will look into that. Mechanistic arrow, guys. So even the arrow need to be specified. Okay, so arrows used indicate the breaking and forming of bond. Itu ada 2 jenis arrow, the half-headed arrow, okay, which shows the movement of single electron ataupun 1 electron, whereas full-headed arrow shows the movement of a pair of electron. Pair means 2 electron. Okay, and it should be curvy, guys. Okay, untuk organic reaction, the arrow should be curvy. It's not straight macam tu. Dia bukan macam ni, straight macam tu. No. Okay, they should be curvy. It shows the movement of electrons. So it needs to be, kalau half-headed arrow, full-headed arrow, 1, 2. Ini menunjukkan pergerakan 2 elektron. Ini menunjukkan pergerakan hanya 1 saja elektron. That's why dia pakai separuh je kepala dia. Okay. Alright, so that is in terms of arrow. Next, the type of organic reaction. Okay, alright, in general, we have 4 types of organic reaction. In general, So we have addition, that means we tambah something into the molecule. Okay, we add in atoms in the molecule. That is what we call addition. Elimination. Eliminate, we want to eliminate something from the molecule. We don't want the hydrogen. Okay, we want to eliminate the hydrogen, the 2 hydrogen from the molecule. So that is what we call elimination, the removal of the atom from the molecule. Substitution, substitute. Okay, ataupun replacement. You ganti. Okay, you don't want the hydrogen. I want the halogen atom to be added into the molecule. So that is what we call substitute. The hydrogen will be kicked out. Okay, and the halogen will be added. Rearrangement, the word re, Okay, arrangement, that means penyusunan semula. Okay, for example, at the beginning, we have double bond between carbon number 1 and carbon number 2. Okay, and then after rearrangement reaction, after rearrangement has taken place, the double bond is now located at carbon number 2 and number 3. So that is what we call rearrangement reaction. Okay, so these are the four general reaction that can take place for organic reaction. Okay, so we will look at into the species first. Okay, free radical, a highly reactive species. It can be atom, ions, or molecule that has an unpaired. This is the word, unpaired electron in its structure. Okay, you must be familiar with odd electron species. Yes, this is the one. Okay, other name ataupun other terms used to represent this odd electron species is free radical. Okay, alright. So example of free radical, see, it has one unpaired electron. So ni kan semua berdua, berpair ni. Ni ada dua elektron. Tiba-tiba ni ada satu saja elektron. So this is what we call free radical. Ada satu lagi free radical. Okay, this one nitrogen, it has one unpaired electron, also free radical. This is also free radical. Okay, the single dot represent the unpaired electron. Profile, electron-rich atom, which enable it to donate an electron pair. Dia kaya dengan elektron. Okay, nucleophile. Okay, it has the ability to donate the electron pair lah. Sebab dia kaya, dia banyak elektron kan. So, family tak dengan Lewis base? Last time kita belajar definition of, theories of acid and bases. Okay, so we have Lewis base. So Lewis base is an electron acceptor. Electron donor kan. Electron donor. Okay, it can be either neutral or negatively charged. Okay, orang-orang yang kaya dengan elektron lah, negative ions. Okay, neutral atom, neutral molecule, but the central has lone pair. Okay, ni neutral ni semua neutral, tapi dia ada lone pair. Carbanion, carbon that become an ion. Okay, carbon that become an ion. See, dia ada extra electron kat situ kan. Dia ada one pair of electron. So normally carbon dia tak jadi dalam bentuk anion macam ni. Dia prefer untuk ada 4 bond. Okay, tapi ni dia ada 3 bond, 1 pair of electron. So this is what we call carbanion. And then species yang has double bond and triple bond. So ini pun electron density is high. Also behave as nucleophile. Electron density dia ada banyak elektron gas. Opposite to that, we have electrophile. Okay, electrophile is a species, okay, that consists of electron poor atom. Okay, that is lack of electron, kurang elektron lah. That's why to represent the lack of electron, we use positive charge there. Okay, which enable to accept the electron. So it has high tendency to accept the electron. So they behave sebagai Lewis acid. Okay, it can be positively charged or neutral atom. So positive ion. So this is also electrophile. Electron deficient, remember, berbau, also behave as electrophile. So opposite to carbanion just now, we have carbocation. The carbon become cation now. Tadi dia become anion, now dia jadi cation. Boleh. Okay, so this is a characteristic of electrophile. Okay, so this is normal neutral atom lah kan. Tapi antara we have C dengan O, dekat mana yang menunjukkan that it is electrophile, electrophilic punya karakteristik. This one, this carbon here. Because carbon, when it shares the electron with oxygen that is more electronegative, we know that they will not share the electron equally sebab dia more electronegative kan. So the oxygen will tend to pull the electron density towards itself, and it causes the end of this part here will be slightly positive and this will be slightly negative. So ini bahagian yang slightly positive is what we call electrophile ataupun become electrophilic. Okay, same goes to this one. Single bonded electronegative atom. Okay, so it is again bonded to more electronegative atom. So this will cause the dipole to appear. Okay, slightly positive, slightly negative. So this slightly positive is electrophilic. Okay, maksudnya the attack will be to this electrophilic part. Okay, this is the fission just now yang saya cakap tadi. The homolytic breaking ataupun homolytic fission and heterolytic fission. Okay, alright. So let's look at the definition for both of them. So imagine we are talking about bond kan? We are talking about bond. So for a bond to form, okay, so one bond consists of two electrons, right? Two electrons that come from different owner, kan? A dengan B, for example. So okay, with respect to this one, okay, so do you have A and B? So this is actually the sharing of this electron coming from A and also B. Okay, alright. So homolytic means two shared electron, the covalent bond split equally. So this one will break, and both of the electron will be returned back to its owner. See, macam ni. Macam this one. So nampak tak arrow yang dia pakai? Dia pakai single-headed arrow, half-headed arrow. Return back to A and also another one will be returned back to B. So this is what we call symmetrical bond breaking, guys. Symmetrical bond breaking. So nampak tak? Each one dapat seorang satu. This is free radical lah. They are radicals, they produce radicals. Okay, this is homolytic. Homo means sama. Apa yang sama? Both of them get the same. Both of them get electron each. Okay, seorang satu. Hetero is the opposite of that. Okay, so they can share electron, but when the bond is cleaved, okay, both of the electron too will be given to other atom, while the other didn't get anything. Itu hetero. Okay, to cleave to each atom. Bond cleave to each atom. Both of the shared electron of the covalent bond cleave to each atom. Both of the shared electron of the covalent bond cleave to each atom. Maksudnya apa ni? Macam this is unsymmetrical bond breaking. This is correct, but this term macam okay, macam confusing je. Okay, so let's look at the example, the mechanism. Okay, so again, this is the bond. Okay, we have two electrons, right? So both of the electron will be given to B, for example. Both, okay, they are big, both of the electrons. So you are going to be using the full-headed arrow, guys. Okay, kena represent it well, okay? So dia akan jadi, seorang jadi cation, the other one jadi anion. Seorang ada extra electron, the other one has no electron. Okay, so you produce ions here. So this is another example. Cl, okay, so you will see this again in alkane. Okay, later on. So they break, so both of the electron will be returned back to its owner. So you must use this half-headed arrow to produce this free radical. Okay, as for this one, okay, both of the electron will be given to one of the atom. In this case, the Cl. Okay, so you pakai satu arrow je kat sini, tapi kepala dia penuh. Right? Sikit lagi bertahan. Madam, sila bertahan. Madam dah tak tahan dah ni. Lagi, maybe I need like 4 minutes, okay? Okay. the organic reaction, the last point kan yang we have in the earlier slide just now. The type of reaction. In general, we have 4 types kan. First, the addition. Okay, alright. So addition can be in 2 forms. It can be electrophilic addition. It can also be nucleophilic addition. But the rule of thumb for addition adalah you masukkan something dalam that molecule. For example, okay, this is molecule A. So it has double bond kan. So this double bond can be broken down. So you nak masukkan this XY into A and becoming XY. So finally the XY is now added into the molecule. So this is what we call addition. Yeah, simple je. Tapi electrophilic addition is because of the neutral molecule is used. And then this part right here, the X lah, kalau kita nak tallykan dengan hydrogen chloride below here, X is the hydrogen. Okay, katalah hydrogen is electrophilic. Okay, compared to Y. Y dia kan more negative kan. So X is electrophilic. So dia akan attack. This one dia akan attack. Tu later lah for the mechanism. But basically, this is called electrophilic addition because it uses the neutral molecule. Okay, alright. So nampak addition. Nucleophilic addition pula sama je addition. So you nak add in the nucleophile. Okay, the nucleophile. So later on, here we have double bond kan. Double bond can be broken down. So bila it's broken. So nucleophile masuklah. Masuk. So this is what we call nucleophilic addition ataupun addition in general. Elimination guys, nak eliminate. Tengok contoh je lah, tengok contoh. Okay, alright. So you have this one. Okay, you nak eliminate the X and Y. Okay, you of course there is condition that you have to consider. Okay, so let's just put that aside later. Ni nak introduce elimination reaction. So XY in the molecule. Later XY is no longer in the molecule. Nampak keluar. So dia jadi double bond kat situ. Dia remove. This is what we call elimination reaction. Okay. So dia ada byproduct lah kat sini. Byproduct. Sebab dah keluar. Next, we have substitution. Substitution is, like I said just now, replacement. Okay. Kita nak ganti. It can be nucleophilic, electrophilic or free radical. Okay. Tengok contoh. Okay, so initially we have Y in the molecule. Now kita nak replace Y with nucleophile. Okay, this is what we call substitution. So at the end, you see, nucleophile is now added, but Y is now removed. Jadi byproduct. This is substitution. Okay, moving on to rearrangement reaction. Penyusunan semula. Okay, so initially, like I said just now, initially, we have double bond between carbon number 1 and carbon number 2. After the rearrangement takes place, okay, the double bond is now changed to carbon number 2 and number 3. So this is what we call rearrangement reaction. Okay, that is all for the organic reaction. So we have a lot of checkpoint, okay, for you to practice with. Checkpoint 3, we have checkpoint question 2, checkpoint 3 still, and then question 3, checkpoint 3 juga. Checkpoint 3 lah, basically ada 3 soalan. Okay, so try to complete all of them. We will discuss them tomorrow. Okay, benda cakap organic chemistry ni memang panjang, banyak cakap lah. So kesabaran tu sangat tinggi di bulan puasa ini. Okay, any questions so far before I end our session today? Ada ke soalan? Anyone?
No, madam.
Okay, so far okay. So far respon 1, nampak feedback bagus.
Okay, madam.
Okay, madam.
Okay, madam.
Alright. Okay, good. Okay, so saya percaya je lah. Dah awak kata okay, saya tak boleh lah nak kata tak okay ni, tak mungkin okay. Tak boleh lah nak cakap macam tu kan. Okay. So, sementara kita masih awal ni, please do something. Okay, you recap, you balik, you just revise. Okay, nak make sure you on track. Jangan tertinggal. Nanti kita akan kena macam laju sikit, so mungkin you akan left behind guys tu. So, please be prepared. Okay, so that's about it for today. So, thank you everyone for your attention and cooperation. And Assalamualaikum. Bye-bye.
Okay, madam.
Madam.